Hi everyone! In today's video we will do a data science project together. If you don't know me, I'm Karina, I'm self-taught data analyst and data scientist. I transitioned from finance to data analytics over 10 years ago and now I share my knowledge with other people online. Today we will build a classification model to predict a loan denial or approval. Once the model is built, we will use unseen new data to make predictions, and then we will look at different cross-validation techniques and what to do when your model looks too good to be true. I found the dataset at kaggle.com. I will leave the link in the description. So it is a loan data and it's actually a very teeny tiny dataset. But when you're creating the model, the process and the steps are exactly the same, whether you have a big dataset or small dataset. So we will work with what we have. To create the model, we will follow the following steps. We will do the data exploration and pre-processing. Then we will split our data into testing and training dataset. Then we will build our model, train our model, evaluate the model, and then we will make predictions with the new unseen data. Let's start. Again, I'm using Jupyter Notebooks. You can use different environments, whatever works for you. We will start with installing two libraries, pandas, so we can read our data, and sklearn, a module that keeps a lot of statistical and machine learning algorithms. So as always, exclamation mark, pip install pandas, and exclamation mark, pip install sklearn. I have both of those modules already installed, so I will not even run the code, but if it's the first time for you, you need to run this line of code to install those libraries. Then we are importing pandas libraries, so import pandas spd. From sklearn, we need to import several specific functions. So for example, from sklearn.model selection, import train test split. Then from sklearn linear model, we will install or import logistic regression. So from sklearn and then from sklearn metrics, we will import confusion metrics, accuracy score, and classification report. Now finally we can read our file, so as always we say df. I keep naming all my data frames as df. You can call it maybe loan data or something more descriptive. To make it faster and easier for me, I call it df equals, we use pandas to read our file, so pd.read_csv brackets, and in the brackets you need to indicate the path to your file. I will just paste it. And then I will print header of our data frame, meaning first 5 rows of the data frame. So this is how our dataset looks like. We have several columns: age, gender, occupation, educational level, marital status, income, credit score, and loan status. If you want to check how many rows your dataset has, you can use .info, so df.info, empty brackets, let's run it. And you can see that our data has only 61 entries, so it's a very tiny data. And we also can see data types of our columns when you use .info. The next step, we need to check missing values. So what we will do, we will say df.isNull, empty brackets, .sum, empty brackets. And it should show us if there are any missing data in our dataset, and we can see that no, there is no missing data. Handling missing values in your dataset is a crucial step for machine learning algorithms. Missing data can negatively impact the performance of your machine learning algorithm. There are several strategies how to deal with missing values. The first one is actually to remove those records, but if you have only 61 rows, deleting may be a bad idea. Another option is to impute missing values. You fill in missing values with statistical methods like mean or mode or median, or more advanced techniques. You can use machine learning algorithms to predict the missing value. The other option, you can use algorithms that support missing values. For example, decision trees, they can handle missing values, and some ensembled methods. Ensembled is a combination of different algorithms. They can also handle missing values. So the next step, we will encode categorical variables. Why we need to do it? Because most of machine learning algorithms, they can't work with categorical data directly. They require numeric input. For example, machine learning algorithms such as logistic regression, linear regression, or neural nets, they require numeric input. Those algorithms, they perform mathematical computations that are not defined for categorical values. For ordinal categorical variables such as low, medium, high, encoding helps to preserve the order of those variables. Numeric values are easier to process, compute, and optimize for machine learning models. Categorical data such as female, male, or occupation or marital status need to be converted in order for machine learning algorithms to work with this data directly. There are two types of encoding. One is the label encoding and one is one-hot encoding. So label is, for example, we have male, female, so male will be 1, female 2, or 0 and 1. Each unique category is assigned with integer value. This method is suitable for ordinal values, but at the same time it can introduce unintended ordinal relationship for nominal data. One-hot encoding creates binary columns for each of the category and assigns values 0 and 1 or true or false. And this method is suitable for nominal values because it avoids implying this ordinal relationship. And you will see how one-hot encoding works. To do one-hot encoding, you can use get dummies in a pandas library. So what we do def encoded, we create a new data frame equals pd, which is pandas, dot get underscore dummies, brackets. In the brackets, at first we say name of the original data frame, which is df, then comma, and then we need to say drop underscore first equals true. And let's have a look how our new data will look like. df underscore encoded dot head brackets, and let's run it. So now we have the new data set called df encoded, and you can see, for example, we have gender underscore male, true, false, occupation analyst, occupation architect. This is how one-hot encoding works. So for each categorical column, new columns were created where all the values now are true and false. It can be also 1 and 0. For example, we had this occupation which had analyst, architect, artist, and now it's all new columns. Dot get underscore dummies in pandas, it's a function that converts our categorical variable into dummy indicator variable. And why we're using this drop first equals true, this parameter is used to avoid so-called dummy variable trap. And what I mean, it's a scenario when the independent variables are multi-collinear. It is when one variable can be predicted from another variable. Let's have a look at all the columns with .info. So df encoded .info, and you can see that, for example, we have gender male, but we don't have gender female because it is unnecessary. That's why we use this drop first, because we have a column gender male, and in gender male we say true or false. So if it's false, it means that our value is female. Similarly, we have for our loan status underscore denied, we don't have loan status approved, because when it is not denied, it is approved. When we are building our ML algorithm, it is crucial to separate dataset into independent and dependent variables. And independent variable, it is features, and dependent variable is our target variable. So this separation allows the model to learn relationship between the features and the target variable. So we will create two new variables, one is x, one is y. X will be our dataset that contains all the features, only independent variables. It will not have the column which says loan approved or denied. That's why we say x equals df underscore encoded, or name of our newly created dataset, dot drop brackets. In the brackets, we need to drop this loan status denied. I will just copy the name so I don't make any mistake here. Comma axis equals 1, and then we're creating our y variable, which will be only our target value, our dependent variable. It will be df underscore encoded, square brackets, and the name again of this loan status denied. Now we need to split our dataset into testing dataset and training dataset. So it will be x underscore train, comma, x underscore test, comma, y underscore train, y underscore test. Now we use train test split that we imported at the beginning. So train underscore test underscore split, brackets. Then we need to say x and y, so x capital Y. And you select the splitting size, so test underscore size. Test size equals 0.2 means that 20% will be testing dataset and 80% will be our training dataset. Imagine that you're just literally taking dataset and you say, okay, 80% of our 61 rows becomes training dataset and 20% of 61 rows becomes a testing dataset. And then comma random state equals random state equals, I usually use 42. So random state controls the shuffling that applied before you split in the dataset. Usually people select 42, 0 or 1, but you can select any number. It's for you, so you can replicate the results. So if you keep using 42, next time you can replicate the same results using the same dataset. Because if you keep changing, every time a result will be new. Why we use 42? I have no idea. So if you know, please let me know in the comments. I think when I was learning, I also was taught use 0, 1 or 42. Why 42 is secret. Specific value doesn't matter as long as it is consistent, so you can replicate the same results. So next step, we need to initialize our model. So we say model equals logistic regression. It's what we imported at the beginning again from our sklearn model, and empty brackets. Now we need to train our model, and you can see that basically training model and creating model is just one little line. So when you do machine learning projects, a lot of your work is actually cleaning the data and getting it into shape, encoding those categorical variables, and then you test the results and go back and but the model itself is just several lines. So when you have a huge code, a lot of them are just cleaning and pre-processing, and the model itself is 2 lines. We initialized our model with model equals logistic regression brackets, and now we are training our model. To do that, you say model that we just initialized dot fit brackets, and then we say x underscore train, comma y underscore train. So those training datasets we're creating. You will not see any details, it's just a model is training. Now we're making our predictions. So we say y underscore predict or pred equals model dot predict brackets x underscore test. So we're making predictions using our testing data. So now we will run our accuracy score, classification report and confusion metrics that we imported at the beginning of this project, and we compare what we predict to our testing dataset. So we say accuracy equals accuracy score brackets, and we compare our testing data to our predictions. That's why we say y underscore test, comma, y underscore predict. And we can print our accuracy, and let's see what we've got. 100%. So 1 meaning our model is 100% accurate. Too good to be true, we will talk about in a minute. Let's look at our confusion metrics. So confusion equals confusion metrics, brackets, in brackets, again, y test, y pred. And don't forget to print your confusion metrics. So printing 9004, it shows that our model is just a perfect. Confusion metric shows true positive, true negative, false positive, false negative. Looks like our model is perfect. And let's also look at our classification report. So it will be, let's say report equals classification report. We use our y test, y pred. And don't forget to print. I keep forgetting to print our reports. Looks perfect, never happens in real life. unfortunately. So classification report is a report that provides a summary of the performance of classification model, and you can see it has recall, precision, F1 score. Quickly, precision is a ratio of correctly predicted positive observations to the total predicted positives. So it's a true positive divided by true positives plus false positive. Recall is also called sensitivity or true positive rate, ratio of correctly predicted positive observations to all observations in the actual class. So it will be true positive divided by true positives plus false negatives. F1 score is a weighted average of precision and recall. So if you look at the breakdown of our reports, we can see that for our class false, so precision is 1, that all predicted false instances are correct. So recall is 1, it's all actual false instances are also correctly predicted. F1 score is of course 1 if our recall and precision is 1, because it is a harmonic mean. And we see that support 9, meaning that there are 9 actual instances of false in the dataset. And we can see for class true as well, again, precision 1, all our true instances are correct. Recall, we see that actual true instances are correctly predicted. F1 is again 1 in this case, and as a support, we see that we had 4 actual instances of true. And it's exactly the same numbers 9 and 4, which we saw in our confusion matrix. You can see actuals and predicted, negative, negative, positive, positive. So this confusion matrix shows that we had 9 falses and we predicted 9 falses. We have 4 true and we predicted 4 true. So our model is 100% accurate. Everything looks too good to be true. Let's assume it is the case. Let's assume our model is 100% correct. So the next step is to make predictions. So we use a model that we just created to make predictions on a new unseen dataset. I will use NumPy library to create a new dataset. If you don't have NumPy, you need to install it. So exclamation mark pip install NumPy. Then we import NumPy. Then I'm creating a new data frame for our new data. So I will say a new underscore data frame equals pd.dataframe brackets. I will create a new data frame with exactly the same columns as our X train. And I will use NumPy to create this empty data frame with all the values equal to 0, and then some of the values I will replace with a specific number. So what I mean, we do pd.dataframe brackets, then I use NumPy.zeros brackets, another brackets, 1, x underscore train dot shape square brackets 1. So I want to keep exactly the same shape as our X train dataset, comma columns equal X underscore train dot columns, because I want to keep everything as it was. So this line of code will create an empty data frame with the same columns as X train, and everything will be 0. And now I'm populating the data frame with new data values. We say new underscore data frame dot add square brackets. We created a new data frame that has zeros in each column, and now I will replace some of the values with new data. We need to say what we replace with what. Index for row is 0. We will replace row, the first row, but that's why index is 0. In Python, indexing always starts with 0. So if we want to replace something in the first row, we need to say row 0. So 0, comma, and if we want to replace age, we need to say the name of our column, age, and let's say 35. Let's also replace income. Again, our 0 for row and column income, we will say 80,000. I will go ahead and change several other columns. I will just copy what I created before. Now we can make predictions with our model. So we will say prediction equals, then we use model.predict brackets. In the brackets, you say the name of our new data frame. So new underscore df. And if we print our predictions, I will show you something. I forgot to give aliases to NumPy. Don't repeat what I've done. NumPy as NP. And if we run, we can see that result is false. We can add several lines of code to interpret our results, so it's easier to understand if the loan was approved or denied. So instead of our print prediction, we would say if prediction square brackets is 0 equals true colon result equals denied. And why it is as the case? Because you remember that our column was loan status denied. So if denied equals true, it means that our loan is denied. Else result is approved. And we want to print our result. Well, I have a spelling mistake. Okay, so our result is approved. This syntax also can be changed slightly. So you see that I said if predictions equals true. You don't need to put this equals true. Python will work without it. For me, it's visually easier to understand. Our accuracy is 100%. Achieving 100% accuracy is usually a sign that something might be off. It's too good to be true, happens very rarely. But of course, we have only 61 rows in our data. Our data is very small, so it can be the case with this specific data. So there are several reasons why your accuracy can be so good. First of all, is a small data set, which is the case with our data. 61 rows. The small data set can lead to overfitting. What it means that model memorized the correct answers instead of learning general patterns. Other option why accuracy can be so high is simplistic data. That is too simple, not too many features, clear, distinct patterns, and that's why the model performs exceptionally well. Data leakage is the next potential option. If the model has access to features that are directly related to the target variable, and so model is cheating in this case, that's how it's called. And of course, it can be imbalanced data set. So if it's heavily imbalanced, so if we have a lot of loans that were denied and just a few approved, then the model of course will say, oh, everyone is denied, because it's imbalanced. So model picks just the majority of data. How to verify these things and improve it? So we need to check this data leakage to ensure that no features in dataset directly provide information about the target variable. We can evaluate this model on a different large dataset, which I highly recommend you to do. So now you can go to Kaggle and find different datasets also around a loan denial and approval, and try this model to apply with a different dataset and see if it works. We can also use cross-validation, check for imbalance. So let's do that. Now we will implement cross-validation. So from our sklearn module model selection, we need to import cross-val score. So we will do cross-validation scores equals cross_validation_score brackets. Then we need to say model, comma, x, comma, y, and we need to select how many folds we want. So let's say 5, CV equals 5, and now we print our CV scores, and we will also print average. So CV scores, min brackets. This is our results, and these scores, they represent accuracy of the model on each of those 5 folds of cross-validation. So first time 100%, second time 92%, 92, 100, 100. We see that it's very consistent. Our model performs very well on most of the folds. I mean, 3 out of 5, we get 100%. So it's perfect accuracy, 3 out of 5. And our average score cross-validation is 97%, as you can see. So it's very high performance. Model consistently performs very well, indicating it's likely not overfitting. but more tests need to be done. Let's check for imbalanced data. So let's see how many denied and approved loans we have in our column loan status denied. So we will use our DF encoded dataset. So DF encoded our column, which was called loan, let me check, I don't remember how it's called properly, loan status denied. And we will do value counts just to see how many values there. Okay, so we have 45 false and 16 true, so it is imbalanced data, which actually will be the case with real data in most of the cases. The next one, we will look for data leakage and feature importance. So we will see if any of the features is more important than others. We will visualize data from matplot library. We will import a pyplot. Again, if it's the first time you are importing those modules, you at first need to run !pip install to install the module. It's not the first time for me, so I will import matplotlib.pyplot, and I'm importing it and call it PLT. I'm also importing Seaborn, which is another visualization module. And let's create visuals for our feature importance. So it will be feature importance equals pandas.dataframe, and in brackets we say feature, and feature it will be our X columns, and then importance it will be model coefficients, and we also will sort the values by importance. When you're creating a visual, at first you always select the figure or its size of your graph. So to do that, you use plt.figure, figure size. I usually keep it 12:8. If you need bigger, you change these numbers. And then using our Seaborn, we creating a bar plot, sns.barplot brackets. Then our x-axis will be importance, our y will be feature, and which data we're using our feature importance data that we just created. plc.title is used to create the title of our visuals. In my case, I call it feature importance, and plt.show the line of code that's used to display the visual. And you can see that credit score is the most important feature in predicting if your loan will be approved or denied. It's funny how you do all this analysis and to get the answer that you probably know just from your logical understanding of the data. Of course, credit score is what bankers look at in order to decide if they give you a loan or not. So we can see that our target variable is heavily imbalanced. There are also several methods how you can address this disproportionate feature influence. You can do feature scaling. You're making sure that all features are on the same scale. So for example, yes, your credit score is already numeric, but it have much larger range compared to other features. I always use an example that if you look at the houses, you have square meters where it can be thousands, and then you have a number of rooms which is 1 or 2. So you can see it both numeric, but one feature is completely different scale compared to another. You can use something that's called regularization. What it does, it penalizes those large coefficients. That's why it's reducing the influence of any single feature. Another thing is a feature engineering. You're transforming some features, for example, our credit score, using log transformation to reduce its range. Also feature selection. So with feature selection, you manually select a subset of features that are less correlated with each other with the target variable. Another option is to balance the data set. You use a method called smooth, is synthetic something. So you synthesize, you create a new data. So we have only 61 rows, but you create more and more of, for example, approved loans to balance that thing. It will adjust these class weights and can help the model learn better. I think this feature influence deserves a separate video, especially feature engineering. That's what you spend a lot of your time doing as a data scientist. As you can see, model creation is just a couple of lines. Usually it's a lot of cleaning happening at the beginning. In our case, data was small, data was clean. No missing values. In reality, you spend just days and days cleaning just to get to a specific format, and then you build a model, then you analyze, and it's either terrible accuracy or too good to be true, like in this case, and you have to go back and create new features. So go back, again, train your model. Training model also takes time, especially if you have a huge data set. It is like a data scientist joke that you click train and it occupies your computer, and then you can go and have tea. Some of the models takes hours. I would run them before I go home, so I know that I can run, go home, come back tomorrow and finally see the results. So it is a secret of data science that model code is tiny. A lot of work happens before, a lot of work happens after, when you work with those features and you look at the numbers and trying to improve. I always share with you the fact that I love working with startups. I spent a lot of my time working with startups. They have an issue with the amount of data. Usually they don't have enough data. You still build the model, and quite often accuracy is, let's say, 60%, which is little, but it's much better than 50, which is a random guess. And you just hope that with more data, with more features, you can improve the model. Once I saw on LinkedIn, there was a big company in Australia, and employees would post every day saying, it is day 564 of us improving the model, and now accuracy went from 82 to 82.2%. You know, if it's a small startup, you probably even don't have this 500 days. You don't know if you will survive up to that point. You don't have money to pay to all these data scientists unless you open AI. A lot of companies can't afford expensive implementation, complicated models, and they're happy to go with something like this. I hope you found this video useful. It's a lot of information. Let me know what things you would like me to discuss in more details. Maybe send me links to some data which we can analyze together, or do some machine learning together. And see you next time.